Hello, Advanced Geometry. So today we are going to do section 2.5, angle relationships, and really dig into this concept of postulates and theorems. So a linear pair postulate. So again, the postulate means it's something that you can assume to be true. It's sort of the basis for building a deductive reasoning system. So this postulate in particular says if two angles form a linear pair, then the sum of the measures of the angles is 180. So that we can assume to be true. It is fairly obvious to be true looking at the picture. But remember, the hypothesis is here, two angles form a linear pair. Well, we don't actually need to state that. You can assume that from the picture. It's one of the few things you can assume from a diagram. So the hypothesis part, you can assume the linear pair from the diagram. And then the conclusion, the sum of the measures of the angles is 180 degrees. So you can see that even in the picture. Again, you can assume lines are straight, and that's going to be 180 degrees. So what we can state here as our conclusion from this picture is that the measure of angle 1 plus the measure of angle 2 is equal to 180, the linear pair postulate. Next is the vertical angles theorem. So again, a theorem is something that you actually need to prove using postulates or properties or any previously proven theorems. So in this case, vertical angles theorem states the vertical angles are congruent. Now, in order to figure out your hypothesis and conclusion, we do need to restate that as a conditional or if-then statement. So pause and take a minute to try and restate this as an if-then statement. Okay, so what you probably wrote, of course, is starting with if. Now I'm going to add a little tiny piece here that you probably didn't write, which is totally fine. But if, and then in parentheses, I'm going to write two lines intersect to form, and you may not have written that piece of it, which is totally fine. But if two lines intersect to form, and then you probably just wrote vertical angles, which is totally okay. And I'm going to start abbreviating with symbols. But if two lines intersect to form vertical angles, then the angles are congruent. And again, I'm going to start using some symbols for that. Okay, so obviously our hypothesis is the if portion. So two lines intersect to form vertical angles. Now again, vertical angles are one of the other things you can assume from the diagram. So if you see two lines intersect, you may assume there are vertical angles there. So we can assume from the diagram that we have vertical angles. In fact, we have two different pair. We have angle 3 and angle 5 are vertical angles, and angle 4 and angle 6 are vertical angles. Okay, the conclusion is the angles are congruent. Okay, you do have to specifically say congruent. So our conclusion is angle 3 is congruent to angle 5, and we could also say angle 4 is congruent to angle 6. Now, it is also true after that that the measure of angle 3 equals the measure of angle 5, and the measure of angle 4 equals the measure of angle 6. But officially, the theorem states the congruency part. Okay, so it is a theorem, so we are supposed to prove every theorem. Now, proofs are the one thing that we are going to de-emphasize greatly this year due to time constraints, but we are going to go through some of them. And so vertical angles theorem is one that we are going to go through. So you don't necessarily have to write down every single detail I'm about to go through. If you would like to put your pencil down and just sort of watch what happens, you can, and then write it later. But really focus on what is going on and try to follow along. Okay, so first we're going to write an abbreviated conditional statement. So just like we did on the front side. So basically, if vertical angles, then we know they're congruent. Okay, that's a very abbreviated if-then statement. So first of all, the given of a proof is always what's in the if, the hypothesis. And as we've talked about, vertical angles can be assumed from the diagram. So in this proof, we're just given this diagram that has vertical angles in it already. Okay, and then we are proving either angle 3 is congruent to angle 5 or angle 4 is congruent to angle 6. Okay, you don't have to prove both of them. So we're just going to prove one pair. Okay, so what you're given is the diagram, in this case the if. What you are proving is the then, which is that they are congruent. So first step in a proof is always what you're given. So we are given the diagram, and the first reason is always just the word given. So that's an easy start. Second, and this is something that you would never come up with on your own at the moment, but we need to be able to relate angle 4 and angle 6 somehow. So we need to figure out something that we know, a postulate or something before this theorem. And really the only thing we can help ourselves with right now is the linear pair postulate. So we are going to use the linear pair postulate to help us prove vertical angles are congruent. Okay, so the first one I'm going to say is these two next to each other. So the measure of angle 4 plus the measure of angle 5 is equal to 180. That's a plus sign. Okay, so I have 4 and 5 add up to 180 measures. Now, I do want to write another one of those, but I don't want to have it isolated from the first. So I want to have something that is related to this equation, but also related to what I'm proving. So I'm going to use angles 5 and 6. So I'm going to say the measure of angle, I'm going to do 6 first, plus the measure of angle 5 is also equal to 180. Okay, both of those are true by the linear pair postulate. And an important piece is that they are somewhat related to each other as you try to build this proof. Okay, so there's some common practices you can use in proofs. One of them is if you notice equations equal to the same thing, a good next step would be to set them equal to each other. So both of these are equal to 180. So therefore, the measure of angle 4 plus the measure of angle 5 is equal to the measure of angle 6 plus the measure of angle 5. Okay, and the reason we can do that is an algebra reason, which is substitution. And that's a property of equality. So basically I took this here and I just replaced it at the 180. Okay, so keeping in mind where we need to go, we need to get angle 4 congruent to angle 6. Well, what you're going to notice is I have an angle 4 right here and an angle 6 right there. So if I can somehow get rid of these 5s, then I am all set. Okay, so we're just going to use some algebra. So we're going to show our work, but I'm going to take away the measure of angle 5 from both sides. So I'm going to say I'm going to take away the measure of angle 5 and the measure of angle 5. Now, with the way we do that in geometry is we actually put a little equal sign between them, and we call this the reflexive property. Okay, and do not worry, you are not going to have to ever do this again. So just sit back and just watch what's going on and try to focus and follow along. Okay, so now that I have the measure of angle 5 equals the measure of angle 5, which is an obvious statement, I can actually subtract that from both sides, and then I end up with the measure of angle 4 equals the measure of angle 6. And again, I subtracted from both sides, so that is the subtraction property of equality. So it seems like we're done, but you do have to make this match the proof statement exactly. So my very last statement is angle 4 is congruent to angle 6. And then that's a silly little definition, which is the definition of congruent angles. All that states is that if the measures are equal, then the angles are congruent. That's the definition of a congruent angle. And there's the proof for vertical angles. So this is something that we would spend a lot of time on. We just don't have the time for it this year. So we'll just do, a couple of proofs here and there, but you won't be tested on anything like that. Okay, so we are going to apply what we have just learned to algebra. So in this picture, we have our two lines intersecting, which means we have vertical angles, but it also means that I have linear pairs. So there are 3 different equations that you could write to help you solve this algebra problem. You only need 2 because you only have 2 variables, but you could write 2 of any of those 3. So I'm going to give you a minute to pause and write equations that make sense for the vertical angles theorem and linear pair postulate. Okay, so the equations you should have written are 4x plus 10 is equal to 3y minus 10. So that's from the vertical angles theorem. Now this cannot be solved because you have an x and a y in the equation. Linear pair, so you can say x plus 10 plus 3x plus 5 equals 180. Or you could write 3y minus 10 plus 3x plus 5 equals 180 degrees. So these are your 3 options. All of them have an x and a y in them. However, you really only need 2 of the equations. So pick any 2 equations and then solve the system. So pause and do that. Okay, so let's go through this. I am just going to randomly pick the first 2. It does not matter which 2 you pick. Okay, the other thing is, if you tried to do this with substitution, that would be a complete nightmare. So I will tell you, most mathematicians will default to elimination. So you really need to get good at elimination. It's really a lot easier than substitution in most cases. Okay, so I'm just going to go through this super fast. So I'm going to rearrange so that I'm in standard form. And then what is this? 7x plus 5y, and then subtract the 10. That's a negative 20. That's a 70. Okay, so these don't match, those don't match, but I'm going to multiply this by 5, and I'm going to multiply this by 3. Okay, I may run out of time, but I'm going to give it a go here. So that's negative 100 times 3, so 21x plus 15y equals, what is that? 510, I think. Anyway, when you add those together, then you get 41x. Those cancel. And then over here you get 410. Divide, and you get x equals 10. Okay, that looks right. And then when you plug back in somewhere, you should get y equals 20. I'm not going to get to that. So you should have gotten x equals 10, y equals 20. Whatever method you chose should have given you those same 2 answers. You should always check to make sure those work in the picture as well. Okay, we'll see you next time.